Now we consider a problem on local extrema of functions. It is a problem that appeared in Joint Entrance Examination Main held on 20th July 2021 in the morning session. The question is based on local extrema, that is local minimum and local maximum at a given point. The problem is, let a be a real number such that the function f of x is equal to ax square plus 6x minus 15 is increasing in the open interval minus infinity to 3 by 4 and decreasing in the open interval 3 by 4 to infinity. Then the function g of x is equal to ax square minus 6x plus 15 has a, the options are 1. Local maximum at x is equal to 3 by 4. 2. Local minimum at x is equal to minus 3 by 4. 3. Local maximum at x is equal to minus 3 by 4. Fourth option, local minimum at x is equal to 3 by 4. We discuss its solution. We have a is a real number and we have the function f of x is equal to ax square plus 6x minus 15. With the information given that it is increasing in the open interval minus infinity 3 by 4 and decreasing in 3 by 4 to infinity, the open interval, we have to find the value of a. Now f prime x is equal to ax square derivative 2ax plus 6. The critical point is given by f prime x is equal to 0, that is 2ax plus 6 is equal to 0. That implies x is equal to minus 3 by a. So we will use this condition, this information that it is increasing in this interval and decreasing in this interval. Given that f of x is increasing in the open interval containing minus infinity to 3 by 4 and decreasing in the open interval 3 by 4 to infinity. This implies 3 by 4 is a critical point of f of x. Therefore, minus 3 by a must be equal to 3 by 4. Therefore, minus 3 by a is equal to 3 by 4. This implies a is equal to minus 4. Using this value of a is equal to minus 4, we have to go to this function gx, ax square minus 6x plus 15, and discuss its local maximum and local minimum. We continue in the next slide. We have a is equal to minus 4. Given g of x is equal to ax square minus 6x plus 15. Therefore, g of x will be a is minus 4, minus 4x square minus 6x plus 15. Now g prime x, calculate minus 8x minus 6. Minus 8 take out common, multiplied by x plus 3 by 4 is equal to 0 to obtain the critical point. So this will imply x is equal to minus 3 by 4 is the critical point of g of x. Now we use a second derivative test for local extrema. Suppose f is continuous on an open interval that contains x is equal to c. If f prime c is equal to 0 and f double prime at c is negative, then f has a local maximum at x is equal to c. 2. If f prime c is equal to 0, f double prime c is greater than 0, then f has local minimum at x is equal to c. If f prime c is equal to 0 and f double prime c is equal to 0, then the test fails. Now let's get back to our discussion, and we have the critical point minus 3 by 4, that is it is c. Further, j double prime x is equal to minus 8, and j double prime at minus 3 by 4, the critical point is minus 8, which is negative. So by second derivative test, that is the first one, f has a local maximum. In this case, g has a local maximum at x is equal to minus 3 by 4. Therefore, by second derivative test for local extrema, g has a local maximum at x is equal to minus 3 by 4. The answer is option 3. So this is using second derivative test. We have discussed the local extrema and found the correct answer. For the same question, there is another test we have. The test is called first derivative test for local extrema. That I will discuss as an alternative method. Okay, let's get into the ALITER, the alternate method. Now, g prime x we have minus 8x minus 6 is equal to minus 8 times x plus 3 by 4 is equal to 0. This implies x is equal to minus 3 by 4 is the critical point of g of x. Notice that if x less than minus 3 by 4, then x plus 3 by 4 will be negative. If x is less than minus 3 by 4, then x plus 3 by 4 is negative. Then g prime x is equal to minus 8 times x plus 3 by 4 is positive. Why? Minus 8 is negative. X plus 3 by 4 is negative. Negative into negative is positive. Therefore, g prime x is positive. Consider the other case. If x greater than minus 3 by 4, then x plus 3 by 4 is positive. Yes. And g prime x is equal to minus 8 times x plus 3 by 4 is negative. Why? X plus 3 by 4 is greater than 0. This is greater than 0. Minus 8 is less than 0. Less than 0 multiplied by greater than 0 is less than 0. It is negative. So, as x is moving across minus 3 by 4, the sign of g prime x is changing from positive to negative. So, thus g prime x changes its sign from positive to negative at x is equal to minus 3 by 4. Now we recall the first derivative test for local extrema. Suppose that c is a critical point of a continuous function f. Moving across this interval from left to right, if f prime changes from negative to positive at c, then f has a local minimum. Second, if f prime changes from positive to negative at c, then f has a local maximum at c. If f prime does not change sign at c, then f has local extremum at c. Now what is happening here? G prime x changes its sign from positive to negative at x is equal to minus 3 by 4. That is the second one. So therefore, by first derivative test for local extrema, g has a local maximum at x is equal to minus 3 by 4. That is, our answer is option 3. This completes the discussion in the alternate method. I hope that you have understood the solution and practice some more problems in this direction. Thank you.